This is lesson 14.2, part 2. In this one, we're going to find some inverses of some trigonometric equations. For example, if we want to know the inverse cosine of 1/2, notice the notation cosine with an exponent of -1 means the inverse cosine. So what we're looking for is on the unit circle, every place where the cosine is 1/2. In your coordinates here, you know that the first one is cosine and the second one is sine. So I have a 1/2 here and a 1/2 here. But from the previous video, you know that the cosine only gives answers in the top half of the circle. And so we would not use the answer in the bottom half of the circle. So the inverse cosine of 1/2 would come back as 60 degrees. Okay, so let's try a few more. What if we have inverse cosine of -1/2? So cosines -1/2 are here and here. Since we want answers in the top half of the circle for a cosine, we would choose this one. And we want our answer in degrees, so it's 120 degrees. We could just as easily get our answer in radians, and it would be 2π3. So next one, we want inverse sine of 1/2. So we're looking for sine to be equal to 1/2, and that occurs at these two locations. Since an inverse sine gives answers in the right side of the circle, we would choose the one on the right side here, and our answer would be 30 degrees. Okay, finally we have tangent, inverse tangent of 1. So since a tangent is sine over cosine, we want a place where the sine and the cosine are the same number, same answer, so that sine over cosine equals 1. So in the unit circle, that's going to be places like √2/2 and the negative pair. Because it has to come out to a positive one, they have to have the same sign. Since the inverse tangent only gives answers in the right side of the circle, we're going to choose the pair on the right side. So this would give us an answer of 45 degrees. Okay, here's another application to this. What are radian measures of all angles whose sine is -0.9? So key word here is all. So if you put in your calculator, you would press the second button, and once you've done that, you choose the sine button, which is actually inverse sine. So that gives you this. Then you put in -0.9, and it will give you an answer of -1.12 when you round it off. In your unit circle, that's going to be down here, -1.12 radians. So it's in this region right here, right there. If we want all answers, this would mean all coterminal angles with that one. So we have -1.12, but if we go around the circle again and end in the same spot, we'll get another one. So if we add another 2π to that, we'll get another angle in the same spot. And if we keep on adding 2π, we'll keep getting more and more angles. So we say 2πn, where n is any integer. So this would give us a whole bunch of answers in this region. But you know that there's also an answer in this region that's also -1.12 for your y coordinate, and sine is y. So how do you get this answer? Well, this answer would be coming around this direction. So that's going to be pi for the top part here, plus this piece is going to be 1.12. So if you take pi plus 1.12, you get 4.26. And then everything coterminal with the black line also is a solution. So it's 4.26 plus 2πn. This would be all the solutions of inverse sine that give negative, or inverse sine of 0.09 any time around the circle. Okay, so if we want to find all radian measures of angles whose tangent is negative 0.84, we would do inverse tangent of 0.84, and we would get negative 0.7. So on the unit circle, a tangent that's negative 0.7 is going to be in this region. So if we want all angles, it's going to be negative 0.7 plus 2 pi n, so that every time you come around the circle and land on that spot, you'll get the same answer. As you know, a tangent is a sine over a cosine. If sine over a cosine comes out to be negative, then that means either sine or cosine was negative. In this fourth quadrant here, we have a positive cosine and a negative sine. In order to get negative 7 in a different quadrant, we would have to have one positive, one negative. That's going to end up being in this region. We would also get a 0.7 because in this region we have a negative cosine and a positive sine. So that's right across the circle. So if we take pi minus 0.7, that gives us 2.44. That's our answer over here in the second quadrant. So all angles that measure 2.44 plus 2 pi n, so every time you go around the circle and you land on that spot, this would be the set of all angles here and here. In the next video, we're going to solve some equations.